Hello, we are starting on page 105. This is the last lesson in our topic of dilations. We're actually starting in the middle of activity 3. We're going to forego the beginning part of this activity. So we're going to work on activity 3, and then we'll end it on half the problems on talk the talk, and then we'll get to our paper assignment at the end of our session. For number 5, though, on page 105. We're going to change some things, but I'll read it first. So we're going to dilate this quadrilateral, this figure, and it says using a scale factor of 3 halves using a specific point, and that is 4, 6. Let's put 4, 6 here. 4, 6 is 4 to the right and 6 up. So 1, 2, 3, 4, 5. Looks like it's right here. So this is our center. Whoops. Our center of dilation, but we're going to change our scale factor. I just want to make it a little bit easier here. We're going to change the scale factor. We're just going to double everything. But I do want to give you some, at least information of if we have an improper fraction or really any type of fraction, right? So this, not really related too much to the lesson right here, but this, let's say you wanted to find 3 halves of a number, I'll say 4, okay? You would multiply 3 halves by 4. How we would do that procedurally, you'd put 4 over 1 and then multiply across, right? 3 times 4 is 12. The denominators, 2 times 1 is 2. And then 12 divided by 2, this will give us 6. Okay, anyways. So kind of a short little bit of a lesson on fraction multiplied with a whole number. But for right now, we're going to use our scale factor of 2. Now, we also have all this table here. We're actually going to figure this out using a different method. So I'm going to cross off the second and the third column. We're going to figure out the last column, which is the coordinates of this new image of P prime, Q prime, R prime, and S prime. So we're going to draw it and approximate the dilation. So this point here, I'm going to highlight this. We are comparing all points P, Q, and R and S to that point. Now this, nothing different than what we've already done. We're just going to find the path from this point to each other point, and then since our scale factor is 2, we'll multiply it by 2. So let's start with the one that's closest to it, which is Q. Right, this looks like it's 2 to the left. So instead of going 2 left, we're going to go 4 left. So we're going to go 1, 2, 3. It's kind of hard to see, but we're going to put a point right here. All right, we'll call that Q prime. Next one, let's go this point to P. So it looks like this is 1, 2, 3, 4, 5, 6, 7 left. We're going to continue. So if we go 7 left, that's 1. I want you to think about this as a step. So going 7 left is 1 step. Since our scale factor is 2, we're going to go another 7 left. So let's go 1, 2, 3, 4, 5, 6, 7 right here. And just so you know, right, these tiny points that I'm putting, you don't have to write. I'm just drawing that so that you know how much I'm counting. But these bigger points like P and Q, or sorry, P prime and Q prime, go ahead and write those in. Next one, we'll go to, I think I might have miscounted. 1, 2, 3, 4, 5, 6. Oh no, I think that's good. Let's go to R. So from this point that's in red to R, looks like we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going 9 down. That's 1 step. Let's go 2 steps. We're going to go another 9 down. 1, 2, 3, 4, 5, 6, 7, 8. We're going to go off the graph here because we did increase our scale factor by 2, or 2. This will be R prime. We'll write the coordinate of that later. And then our last one here, let's go to S. So S looks like it's going 1, 2, 3, 4, 5, 6, 7, 8, 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9 left. 9 down, 9 left. Let's continue from S for our second step. That's 1 step, right? When you think of like stairs, where it goes up and to the side. So this is going down and left, 9 and 9. So let's continue that. Let's go down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or we'll have to approximate that. But we're going to connect all these points and then write the coordinates in the table. I'll put this in red so we can just kind of see the differences between the different colors. Right here, right there. We're going to connect it to Q prime. And then finally from P prime to Q prime. And then also forgot to label S prime. All right. So here, let's go ahead. This looks like the original figure. It is 2 times as big. P prime, that is the coordinate from the origin. If we go left and up, that is -10, comma, that is a height of 6. Q, looks like from the origin, we're just going up 6. So this is 0, 6. R prime, we go 4 to the right and 1 more past. So it looks like that is 12. So that is +4 since we're going to the right. And 12 down, so -12. All right, and let's figure out S. Okay, that is 9, 10, 11, 12, 13. Looks like we're going 14 to the left, so -14. And we're going also 12 down. All right, so I think fairly painless. We're just going, we're figuring out the path and multiplying it by 2. So that's slightly different than what the book has asked, but I think slightly easier using this method. Okay, let's go to the next page, page 106. So this was an example of an enlargement. Let's go through one more example of a reduction. And we're going to reduce this by, should we keep this? Let's use 2/3. Let's go and cross off these 2 columns. Dilate this figure using a factor of 2/3. And we're going to use the point of -2, 0 as the center of dilation. So we got to figure out where -2, 0 is. From the origin, we go 2 left and 0 up and down. I'll go ahead and highlight this point so we know that where we are starting. That's going to help us when we determine the path for each one of these. And we're going to be multiplying with 2/3. So we will use the fraction here. I think the one that's closest to it, let's go to S from this point. So it looks like we're going down, 1, 2, 3, and we're going to the left, 1, 2, 3. I'll put it over here. Let's put S, this is 3 down, 3 left. I've now got to multiply this or find what is 2/3 of 3. I mean, you can try to do that mentally, 2/3 of 3. But if you're not sure, you can always do it procedurally. That is multiplying 2/3 by 3. Now, like I said, when we do this, we're going to put this over 1. Multiply across. 2 times 3 is 6. 3 times 1 is 3. And this actually simplifies to be a nice number. It is 2. So 2/3 of 3 is just 2. So that tells us for S prime, instead of going 3 down, we're going to go 2 down and 2 left. So let's graph that. 2 down, 2 left from this red point, -2, 0. 2 down, 2 left. Looks like S prime is right here. We'll write that coordinate. I guess we can write that coordinate now. We actually are starting at the bottom of this row. That looks like it is 1, 2, 3, 4 left, so -4, and 2 down, so -2. Okay. We are going to get some points where it's not a whole number. Let's go to R though. So R looks like we're going to go down 1, 2, 3, and then to the right 1, 2, 3, 4, 5, 6. So we'll put it here. R is 3 down, 6 right. So what is R prime? We already did the math for 3 down, right? We know that we're going to go 2 down, right? 2/3 of 3 is 2. But what is 2/3 of 6? I think we can still figure that out, but I'll put the scratch work off to the side. 2/3 of 6, put over 1. This is 12 over 3, and 12/3 is 4. So instead of going 6 right, we're going to be going 4 right. So from the point, let's count down 2 and 4 right. 1, 2, 1, 2, 3. Looks like we're right here for r prime. And as we can see, right, our image points are inside of this quadrilateral, this trapezoid. What is the coordinate of that point? From the origin, we're going to go 2 right, 2 down for r prime. That is the coordinate 2, comma, -2. All right, so we've got 2 of these points. And then let's go to the other ones. These other ones, like I said, they are going to be fractions, but let's get comfortable with it. Let's go and determine for this one. Let's go to, I think the closest one, let's go to P. This is up 1, 2, 3, 4, 5, 6, and 1 left. Up 6, 1 left. So P prime, we already know, we've already done 2/3 of 6. So instead of going up 6, we're going to go up 4. And what is 2/3 of what moves left, which is just 1? 1 times 2/3, well, 1 times anything is just that thing. So 1 times 2/3 is actually just 2/3. So the way I want you to think about that is, like, let's say we have a rectangle. You don't have to draw the rectangle, but if I make this into 3 sections, 2/3 means that 2 of these sections are shaded. So it's not quite a complete unit. So we are going to be moving 2/3 to the left, but it won't be a complete square that we move. Anyways, let's get into here. Just zoom in a lot. We're going to go up 4, 2/3 to the left. So up 4, 1, 2, 3, 4, and 2/3 to the left looks like it's going to be right up. 1 to the left would be here, but 2/3 is going to be like right here. It's a little bit past halfway, not quite all the way to that 1 to the left, but this is P prime. I'll just make that a little bit bigger. All right, we'll connect that later, but let's go and determine the coordinates. So the coordinate here, I'm gonna draw the arcs, but I'm gonna erase it. This is 1, 2, and if you line this up right here, this is, we know that that's to be 2/3. So this is 2 and 2/3 to the left. All right, so let's write that in. For P prime, this is, we're going to the left, so -2 and 2/3. We've got a mixed number here, and we're going 4 up. All right, so that's a little bit different, but you know, I think it's good to practice these things that are, maybe we don't get to practice, we practice a lot with whole numbers. All right, let's go to Q. We know that from this point, we're gonna go 6 up. And we're gonna go to the right. We're gonna go to the right, 1, 2, 3, 4. And we already did the multiplication on these numbers. So we know that 2/3 of 6 is 4, so we're going to go 4 up. And 2/3 of 4, did we do that multiplication? We did not. So let's find 2/3 of 4. This looks like it's also going to be a improper fraction, but we'll put this over 1. 2 times 4 is 8, and 3 times 1 is 3. We can make this into a mixed number. Typically, we'll make it into a mixed number if we're graphing. 3 can go into 8. Looks like if you skip count by 3, 3, 6, 9. Without going over, it can go into 6, which is 3 times 2. 6 from 8 has a remainder of 2, right? 8 minus 6. So 2 and 2/3. So it looks like we're, instead of going 4 to the right, we're going to be going 2 and 2/3 to the right. So careful counting there. Let's move for Q prime. One more time. 4 right, or 4 up, 2 and 2/3 to the right. So 4 up. 1, 2, 3, 4, and 2/3 to the right. 1, 2, and 2/3. Almost to that other tick mark, but not quite. This is Q prime. All right, let's write the coordinate for that. From the origin, looks like we're going to go actually 2/3 to the right. So this is positive, just this proper fraction. 2/3 to the right and 4 up. Okay, and then let's connect all points. Or you're welcome to use a protractor if you like to draw this. Now, all these tiny tick marks you don't need to draw, but I just did that to kind of convey this. But these points, the pre-image point or image points, you'll need to connect. All right, and we have two figures that are similar, right? Same shape, different size, but same interior angles. The side lengths are that form that ratio of our scale factor of 2/3. All right, and then let's get to this. We're just gonna do one problem on page 107. We're given a center at some point on the coordinate grid, and a scale factor, it looks like in both these problems, are 2. We'll just do one of them. Let's choose the first one. So the center of dilation here is 3, 3. So let's plot that point. 3, 3 is 3 right, 3 up. I'll highlight this. And a scale factor of 2. So we know from the path of all these, you're just going to multiply by 2. We can think about these steps that we take here. So like from this point to B, I'm going to draw an arrow here. I'm going to erase this arrow, but that arrow is going down 1, 2, 3, 4, 5, 6. And you would just continue going down 6. So that's one step. This is the second step since our scale factor is 2. 1, 2, 3, 4, 5, 6. It should be at that point right there. You know what, I'll put that point here, and I'm going to erase these arrows with the arrowheads. Get rid of that, get rid of that. Okay, so this point is B prime. Let's go to C next. That is 2 down, and 1, 2, 3, 4, 5, 6. 6 left. So we'll continue that. Going 2 down, 1, 2, and 6 left. 1, 2, 3, 4, 5, 6 right here. Let's put that point. That is C prime. Again, I'll get rid of these arrows. Right, so since our scale factor is 2, this tells us take that step twice. So that step was down 2, 6 left, and we did that path twice. We're going to do the same thing for A. Going down 1, 2, 3, 4, 5, 6, and left 1, 2, 3, 4, 5, 6. That's one path or one step. So let's continue that. Going down 6, left 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is A prime. We'll connect all these points. And there you go. Right, you get a triangle that is twice the height, width of the original triangle. Okay, you're welcome to do B as practice, but let's go to talk the talk, and we'll end our video here. This is titled location, location, location. We're going to answer just part 1, or number 1, part A and B. 2 and 3 we're going to forego. Number 1, what strategies can you use to determine whether two figures are similar? And then A, how can we figure out if two figures are similar? The coordinates are on the coordinate plane. So it depends, but right, for this, we can say, we'll say multiply the coordinates by a scale factor, or that's where we multiplied the coordinates. Like if the scale factor was 3, we multiplied the x and the y value by 3. Multiply the coordinates by a scale factor, we'll just say it there, and that would be in order to get the other coordinates as well. But this is only true if the center of dilation, we'll just say center, is on the origin. That's the only thing you can use that for. B though, this will work regardless. The figures are not on a coordinate plane. Now we did this with measuring using a protractor. The figures are not in the coordinate plane. We just have a grid. You can do one of a couple of things. You can measure these side lengths and identify a common ratio / factor. Okay, so an example here is, let's say, you don't have to draw this part, but let's say we have two triangles here. Like these might look like they're similar, but how do I know? Let's say the side lengths for this is 2, 3, and 4. And this one here is 4, 6, and 10. There's a common factor, there's a common ratio. Right, as you can see with these first ones here, right, 2 to 4, I think I can identify what's happening there. Let's say 3 to 6, looks like all of these here, all corresponding sides, you multiply by 2, right? So that's that common scale factor. So look at the side lengths there and identify that. We can divide here. So an example in red, I'll take the image, which is 4, and the pre-image, which is 2. 4 divided by 2, that's 2. Another example, what we have in blue, we have, oh, sorry, I wrote the wrong number. Apologize for that. This is supposed to be 5. In blue, this is 10 divided by 5, which is also 2. And the last one, I put in yellow. It's kind of hard to write in yellow, so I'll put in orange. 6 divided by 3, also 2. Notice how for this, these values, scale factors, are exactly the same. This tells us what the scale factor is for this dilation. All right, anyways, we're going to finish up this lesson and topic on the assignment. You have on the front side, practice numbers 1 and 2. And on the back side, we're going to say 3, 4, and 5. So going to give that all a shot. Pretty much just numbers 1 through 5. All right.